Okay, so today we're going to kind of build upon what we've been doing the past couple of days. Nothing super different, okay? Couple tips as we look at a little bit more complex problems. The first one, it's okay. Are you done? Okay. The first tip is that you're always going to want to rewrite your quadratic or whatever polynomial you have in standard form, meaning you want to put the highest power at the front and work your way down. So with a quadratic, that's ax squared plus bx plus c. If it's a cubic, put the cubed term at the front, kind of just work your way down. Okay? If the leading coefficient, and by the leading coefficient I mean like our a value, if that's negative, you want to factor out a negative. Okay? It's a lot easier to factor if you don't have a leading coefficient that's negative. I'm not saying it's impossible, but I just see lots of people make that mistake with the signs and stuff. So if you can factor it, I want you to go ahead and do that. Sometimes in factoring, you're going to do one thing, you're going to apply one rule or one process, but then you're going to need to do it. You're going to need to factor some more. Okay, one of your factors can be factored further, so you need to check for that. So let's look at number 1. Negative 10 plus 31a minus 3a squared. Let's start by rewriting this in standard form. So I'm going to have negative 3a squared plus 31a minus 10. Okay, notice that my leading coefficient of negative 3 is negative. But I don't want to pull out a negative 3 because then I'm going to have fractions here. So let's just pull out the negative. Okay? So I'm going to factor out a negative, and I'm going to have 3a squared, then what? Minus 31a plus 10. Okay, be careful with your signs changing there. Yeah?
So before you factor out the negative, do you multiply negative 3 by negative 10? See if that adds up to 31.
I mean, you can't, this is still factorable when leaving the negative in. I just think it's a lot easier to factor something where the leading coefficient isn't negative, because then you're not dealing with like a binomial that's got a negative first and all that stuff. Okay? All right, so now it's just a normal trinomial, so let's go ahead and factor. Multiply 3 times 10, and what do I get? Okay, a positive 30. So my sign of my factors either needs to be plus plus or minus minus. Look at our middle term. What should our signs be? Minus minus. What should I use? Negative 1 and negative 30. So we're going to split that middle term, keep that minus sign. I have 3a squared minus a minus 30. Sorry, minus 30a plus 10. All right? Let's group it and take out our greatest common factor. What comes out of my first group? Okay, and I'm left with 3a minus 1. What comes out of my next group? Good. Why negative? Good. We've got that negative in front, so we want to pull out a negative 10. And then what am I left with? Do they match? All right, so I have negative a minus 10 times 3a minus 1. Okay? All right, look number 2. How many terms do we have? 4. Okay? Now, anytime we've had a trinomial, like in number 1, we split the middle term to create 4 terms, right? So that we could group. But this already has 4 terms. So what do you think we should do? Yeah, just start grouping. Yeah, it's already got 4 terms for us. So let's just start grouping. Group your first 2. Group your last 2. What can I pull out of my first 2? 4x squared. Good. What is left? Not x minus 16. X minus 4. Good. Okay? What can I pull out of this one? Negative 9. And what's left? X minus 4. Do those match? Yep. So we're good. So I've got 4x squared minus 9 times x minus 4. My question to you is, are we done? No. Who knows why not? Yeah, we have 4x squared minus 9, which falls into what rule? Difference of squares. So I'm going to want to continue and factor that some more. What squared gives me 4x squared? What squared gives me 9? 3. So 2x is A, 3 is B. So how does 4x squared minus 9 factor? Good. Is that my answer? Good. Make sure you bring that down. Okay? Remember how we talked about losing points on the easy stuff? I mean on the hard stuff, not on the easy stuff? Forgetting to bring down that other factor is a silly place to lose points. Sean? No, because the signs would have either need to have been all different in one of your binomials. But at the end, if that is what you end up with, factor out the negative, because you don't want a negative at the beginning of your binomial. Okay, any other questions on number 2? All right, let's keep going. X cubed minus 6x squared minus x plus 6. All right, I want you to try this one on your own. Just number 3. Can you keep going? Yeah, good job. Okay, so I hope that in your first step, you were able to get to x squared minus 1 times x minus 6. Yes? But that's not the final answer, is it? We've got to keep going on that. That's difference of squares, so it's x minus 1 times x plus 1 times x minus 6. Any questions about that? All right, let's look at number 4. Okay, number 4 has 2 variables in it, which we haven't necessarily seen before. We are not going to panic. Nothing has changed. Okay? It's still a trinomial. We're going to use the same rules that we've used in the past for trinomials. Okay, so I'm still going to treat this as a normal trinomial. So multiply your a value times your c value. What's that? -3. And what is that? So that means I need positive and negative. So what 2 factors am I going to need? Hearing lots of different things. -1, +3. Good. Okay. Notice when I split the middle term here, I had a variable of a, and when I split it, my variable stayed a, so that I could add them together and get back to that, right? Okay, so right now my variable is ab. So when I split it, my variable has to stay ab. So this is a squared minus 1ab plus 3ab minus 3b squared. If I combine these middle terms, do I get back to 2ab? Yeah. So no rules have been broken. I just noticed that whatever the variable of the middle term is, that's the variable when I split it. Okay? Now we just treat it like normal. Group it. What can I pull out of the first 2? So I'm going to have a times a minus b. What can I pull out of the second 2? So plus 3b times a minus b. Do they match? So I get a plus 3b times a minus b. On these, I really like to double check that they worked because it's easy to get kind of freaked out when you see more than one variable. Even though, what do we notice? It's just the same, right? It's just the same. But go ahead and let's think about double distributing that a. So I would get a squared minus ab. Then could I double distribute that 3b? So I would get plus 3ab minus 3b squared. When I combine those middle terms, I'm going to get plus 2ab minus 3b squared. All right, let's try it again. Like number 5. Two x squared plus 7xy plus 3y squared. It's a trinomial. So we're going to treat it like a trinomial. There's no GCF, so I can't pull anything out. So we start by multiplying our a value and our c value. 2 times 3 is 6. So we want positive, positive, or negative, negative. Which one? Positive, positive, and what do we want? Plus 1 and plus 6. So I keep my first term the same. When I split my middle term, what variable must stay with my middle terms? All right, so plus xy plus 6xy plus 3y squared. Everyone okay with that step? Okay. Group it. What can I pull out of the first 2? X, good. What's left? Okay, what can I pull out of the next 2? 3y. I get 2x plus y. Do they match? So I have, you did it right. X plus 3y times 2x plus y. Questions? Okay. Look at the next one. Go ahead and write that down. There's a time-consuming way to do this and a much less time-consuming way to do this.
Yeah, tell us the
Yes, I will tell you the much less time-consuming way, okay? The long way is, I'm not doing it, I'm just telling you. The long way would be you could distribute your 5, you could square a minus 2, combine like terms, and factor. Wouldn't be hard, right? We could do it. It's just longer. What I want you to notice, how can I rewrite a minus 2 squared? How can I represent that? Yeah, so I could rewrite this as 5 times a minus 2 plus a minus 2 times a minus 2. Does anyone see what we could do? Sean? No, not necessarily. Well, kind of. I think you're kind of on the right track. You're not just going to take out A. What's our GCF here? A minus 2. 5 is being multiplied by A minus 2, and A minus 2 is being multiplied by A minus 2. You see that? So our GCF is A minus 2. So I'm going to pull out A minus 2 as my GCF. And let's talk about what's left. 5 plus A minus 2. See that? Because that's what's left right there. Now all we need to do is simplify this. 5 plus A minus 2, how does that simplify? A plus 3. This is all adding. This is 5 plus A minus 2, so I just combined like terms. Okay, I know there's some questions, but I can't hear them all at once, so I need you to be quiet for a second, and I need you to raise your hand if you're what first step that you got confused on. Yes, ma'am. Okay, because this part right here is A minus 2 times A minus 2. So if I wanted to get back up here, I would have to have A minus 2 times A minus 2 to give me A minus 2 squared. Okay? Other questions on how I did this? Here to here? Here to here? Okay. So I know. Do you agree that the part I've underlined, that A minus 2 is a GCF? Okay? So I have to pull out my GCF, and then I have to think A minus 2 times what gives me 5 times A minus 2, which is 5. A minus 2 times what gives me A minus 2 times A minus 2? So I need another A minus 2. Okay? Then in this step, I just simplified 5 plus A minus 2. Okay? Now, if you had multiplied this all the way out, combined like terms, and then factored, you would still get down to this. You can still do it that way. Okay? I can check it when we're done. All right, we good? All right, look at number 7. Give it a shot. Again, time-consuming way, less time-consuming way. So try and find the less time-consuming way. Okay. What rule should you be using? Difference of squares. This is m plus 3 squared minus 7 squared. So what's your A? M plus 3. And what's B? 7. So m plus 3 plus 7 times m plus 3 minus 7. Yeah, let's simplify. M plus 10 times m minus 4. Again, could you square m plus 3, combine like terms, and then factor? Yeah. Just a little more time consuming. All right, let's look at number 8. W to the 4th minus 8x to the 8th. Ideas? Going to use difference of squares. Very good. We've got powers that are even, which means they can be squares. So let's think. What squared gives me w to the 4th? W squared. Minus what squared gives me x to the 8th? X to the 4th. Nope, it's x to the 4th because when it's power to a power, okay, when you've got an exponent being raised to another exponent, you multiply, okay? The idea is if I had x to the 4th squared, that's the same as x to the 4th times x to the 4th, right? You agree with that? Which is x to the 4th times x to the 4th. So that leaves me with x to what power? X to the 8th. Okay, you remember that rule now? You could try it, yeah. All right. All right, so this is going to be, what is it going to be? Hang on, let's do it once first. Okay, am I done? Yeah, we got to do it again, right here. Okay, this is difference of squares again. So this is w squared minus x squared squared. So this is w minus x squared times w plus x squared. Nope, a minus b times a plus b. A is w, b is x squared. Can I keep factoring w squared plus x to the 4th? No, why not? It's addition. Good. So then it's going to be, sorry, my air slate keeps dying, but we're almost done. So this is w squared plus x to the 4th. Don't forget to bring down the term even when you're not doing anything with it. Do what? Yeah, I can't do this one because it's addition. I can't do this one because w is not a perfect square. Okay? Okay? Questions? Okay. Shh. There's so many side conversations. I can't hear what are real questions and what aren't. Reese? Yes, this is the final answer. W minus x squared is not a difference of squares because w is not a perfect square. It would have to be w squared to keep going. Okay? All right, let's talk for a moment about your quiz tomorrow. Sorry, are there any other questions? Okay. Let's talk for a second about your quiz tomorrow. Your quiz covers 3.1 through 3.3, or 3 days of factoring. Okay? And it also includes the memorization of the perfect squares and perfect cubes. Okay? Remember that you're responsible for squares 1 through 15 and cubes 1 through 10. It is 90 seconds for that part of the quiz. I'll pass it out to you Everyone will flip it over, write our names, start time. You'll have 90 seconds. There will be a column of squares and a column of cubes. They will be mixed up, so do not just memorize them in order, okay? It's probably a good idea to do flashcards or something so you can keep mixing them up.
So is it going to be like we're going to be given the number and we need to know the cube?
It's going to say like 3 squared equals blank,
And it's instead of having the actual number, we just need to know the number.
okay?
So it's not going to be both ways.
Nope, it's only going to be that way, okay? And then you'll pass, after the 90 seconds are up, you'll pass that in, and then you'll start your quiz. It'll take about 30 minutes.